Last month, I was sitting by the window on a flight. Before takeoff, while looking outside, I noticed a small hole at the very bottom of the window. Tiny, maybe half the size of a pencil tip. My first thought was, is this normal? I showed it to the passenger next to me. They were surprised too. When I started researching at home, what I learned was incredible. That hole wasn't just simple ventilation. If that hole didn't exist, the window would probably blow out and everyone in the cabin would be in danger. Now I'm going to tell you the story of that hole. Because this isn't just a hole. It's an amazing solution where physics, engineering, and safety come together. So what exactly does that hole do? But to understand this, we first need to understand how airplane windows work. Because airplane windows are much more complex than you think. Now think about it. Passenger plane, flying at 30,000 feet. The temperature outside, around -60 Fahrenheit. The air pressure outside, almost zero. But inside the cabin, you're sitting comfortably. Normal temperature, normal pressure. You can breathe. You feel comfortable. So how is this possible? The answer, pressurized cabin system. Aircraft pressurize the cabin artificially. They simulate sea-level pressure inside. But this means there's a massive pressure difference between outside and inside. And this is where the windows come into play. Now I'm going to tell you something. You might be surprised. Airplane windows aren't a single pane of glass. Not two panes either. They consist of 3 separate layers. Yes, 3 panes. Outer pane, middle pane, inner pane. Each one has a different job. The outer pane, the thickest one, because it carries the main structural load. It handles the pressure difference. It withstands the low pressure outside the atmosphere. The middle pane, you can think of it as a backup. If there's a problem with the outer pane, the middle pane takes over, like a 2-layer safety system. And the inner pane, the thinnest one, its job is actually quite simple. It separates you from the outer and middle panes. So passengers don't touch the outer pane, can't damage it. It also helps with thermal insulation. But here's the interesting part. Only one of those 3 panes has that small hole, the middle pane. So why? Now, this is very important. Between the outer pane and middle pane, there's a small gap, an air-filled gap. And the air in this gap is slightly different from the pressurized cabin air. If that hole didn't exist, the air in that gap would be trapped. And when pressure changes occur at altitude, it would cause problems. That small hole provides a connection between that gap and the cabin interior. It equalizes the pressure, so the middle pane doesn't experience unnecessary stress. Because the real work is on the outer pane. The middle pane is just a backup. And thanks to that hole, the middle pane stays intact for a long time. Plus, that hole does something else. Moisture control. At high altitude, temperature differences are huge. Warm inside, freezing outside. This difference can cause condensation between the glass layers. Fog, moisture, ice formation. But that small hole allows airflow, so the windows don't fog up. You can see outside clearly. Actually, this design is the result of years of engineering experience. In the 1950s, when the first jet passenger aircraft emerged, window design was very different, and some problems occurred. Especially, there was a plane called the de Havilland Comet, the world's first jet passenger aircraft. But within a few years, several accidents happened. Investigations showed that the problem was related to the windows. Square windows had been used, and at the corners, stress concentration occurred. Metal fatigue, cracks, eventually structural failure. After these accidents, aircraft engineers learned a lot. They learned that windows need to be oval, because an oval shape distributes stress evenly. No corners, no points where stress can accumulate. And they developed the multi-layer glass system. Now airplane windows are much safer than those days. Now let's get a bit more technical. How big is the pressure difference exactly? At 30,000 feet, The pressure outside is about 0.3 atmospheres. Inside the cabin, they maintain it around 0.8 atmospheres. So the difference is around half an atmosphere. This might seem small, but it means enormous force. On every square meter, thousands of pounds of force. Think about it. Every window on the plane has to handle that force. And it's not just pressure. There are also temperature changes. When you take off from the ground, maybe 70 degrees Fahrenheit. At cruise altitude, outside it's -60. Materials expand, contract. They call this thermal stress. That small hole also helps in dealing with these stresses. It provides flexibility to the system. There are other interesting details about airplane windows. For example, the seal around the edge of the window, like rubber, but a very special material. It provides airtightness, but at the same time, it allows for thermal expansion. The glass can move, but air doesn't escape. Then there's the thickness of the window. The outer pane is typically 10 to 15 millimeters thick. Might not seem very thick, but it's made from special material. Acrylic or polycarbonate. Some aircraft use plastic instead of glass because it's lighter and more flexible, more resistant to breaking. Weight is very important in aircraft. Every pound means fuel consumption. That's why engineers optimize every detail. They try to minimize window weight, but without compromising safety. Now you might be wondering, what if that hole gets blocked? What if it closes up? Actually, it wouldn't be a major problem, because the real structural safety is in the outer pane. Even if that hole gets blocked, the outer pane continues to do its job. Only the middle pane would experience a bit more stress, and moisture buildup might occur. But cabin pressure doesn't drop. The window doesn't blow out. So that hole is a safety feature but not a critical component. Aircraft manufacturers put windows through very rigorous testing. Pressure tests, temperature tests, impact tests. They throw heavy objects at windows to test durability. They do thousands of pressurization cycles to measure fatigue resistance. And the result? Today's airplane windows are incredibly safe. According to statistics, a serious window-related failure is extremely rare. As I researched this topic, I realized something. In daily life, we overlook so many things. We board a plane, look out the window, and don't think about it. But every single detail has been very carefully thought through by someone. That small hole is not a coincidence. Dozens of engineers worked for years, did physics calculations, ran tests, ran simulations, and the result? Millions of people fly safely every year, looking out the window, watching the clouds, and that small hole silently does its job, equalizing pressure, controlling moisture, protecting the system. To me, this is a beautiful example of the power of engineering. Invisible, but vital. Simple, but smart. So, what did we learn today? Airplane windows consist of 3 layers. Each layer has a different job. The middle pane has a small hole, and that hole equalizes pressure. It also provides moisture control. This design is the result of years of experience and engineering knowledge. Aviation safety consists of such small details. On your next flight, if you sit by the window, take a look. You'll see that small hole. And now, you know how important it is. Maybe you'll show it to the person next to you and tell them the story. Because sometimes the most interesting things are hidden in the smallest details. I hope this video interested you. I hope you feel a bit more curious about airplanes. And I hope your next flight will be more informed. Because now, you'll look at that window with different eyes. Thank you for watching this video. If you enjoy this type of content, you can subscribe and follow me. You can write in the comments what topic you would like to see in the next video. Do you have any other daily details you're curious about? Share them with me. See you in the next video. Have a good flight and stay curious. Goodbye.